So we are going to now look at how to calculate the slope of a line, and all of the slopes will be from lines of best fit, not from the actual data points unless the points are actually on the line of best fit. So once you have drawn your line of best fit, you don't worry about the data points that you've collected, you've already put them on the graph. So looking back at the graph that we had looked at in our other video, the line of best fit is drawn here in purple, and so I'm going to be calculating the slope of the line off of this line of best fit. Now, one of the important points to remember is that the units of the slope are your y-axis units, which are meters per second, over your x-axis units, seconds, which gives us meters per second, or meters per second squared. So part of what the units of the slope tell you is what values go on the y-axis and what goes on the x-axis. So if I have units of my velocity being meters over seconds, that tells me that it comes off of a graph in which the y-axis values are meters and the x-axis values are seconds. The second point that's really important is that I use the points that are on the line of best fit that are at an intersection and require less guesswork. So I've chosen 2 points here because it's right at an intersection, and this is a wonderful reason to use graph paper. And it's easy for me to say that this is 3 and 1.5. And then again here, I have to go all the way down to here to find point 2 at a nice intersection, and that gives me 9.5 and negative 8.5. So they don't have to be any of the data points. They don't have to even be near. Like if I had a nice intersection point right here, I could have used that one. So as long as they occur at a nice intersection point, it makes it a lot easier. So I now have my 2 points to use point slope form, 3 and 1.5, and 9.5 and negative 8.5. So then I just use slope as change in y over change in x. So my change, remember, is always my second point values minus my first point. So negative 8.5 is my first y value that I use, and negative 1.5. So that gives me a change in my y value of negative 10. And my change in x will be 9.5 minus 3, or 6.5. And just to the point of reference, if time is on your x-axis, your change in x should always be positive, just to make sure that you're subtracting the right thing. So negative 10 over 6.5 becomes negative 1.5, and then I have to put the units in, which are my y over x-axis units, so meters per second over seconds, or I get negative 1.5 meters per second squared. You can either leave it as meters per second, or change it to meters per second squared, whatever you feel most comfortable with at this point. Notice that I always convert my answer into a decimal, and I don't use fractions. Fractions are not used in science class. They are used in math class, but not in science. So if you present your answer as a fraction, you will get points off. It needs to be converted to a decimal. I, just to make things easier for my own brain, will always put negative numbers in parentheses in my answer, just so that it's easy for me to double check and make sure that I have a negative value.